Let's get started, okay? A lot of people don't like algebra, rightfully so. It deals with letters that should be in English, but apparently it's also in math. So you just have to get accustomed to it. And it's not too bad because it actually helps you to understand what you're doing. You think you don't use algebra, and a lot of people think that algebra stops in high school, but you're always using algebra. You're always using it, especially when you're shopping, when you're in the supermarket and you have to buy two different types of detergents. You would say if detergent A costs 33 cents, well, not, let's say $33, and detergent B costs $34, and then you look at the fluid ounces, then you could compare them and say which one is worth it. You know, you always say, I would do it with bread. You would say, if one bread costs, let's say $1, how much would 10 bread cost? Right there and then you will be using algebra, because you would say if 1B costs $1, how much would 10B cost? And you put an X, right? It's not as hard as you think, okay? So, let's get started. What is algebra? Algebra is a part of math in which letters and other general symbols are used to represent numbers and quantities in formulae and equations. And this came straight out of Google's definition. You could always look up stuff when you don't understand. Here we have addition and subtraction in algebra. So if you have A plus A, that would give us 2 A's. The same as if you were to say you had 2 pens in your bag, you would say 1 pen plus 1 pen will give you 2 pens, or P plus P will give you 2P. The same idea. Now look at it. If you have 3 apples and you took away 1 apple, you would now have 2 apples. And that way, you could write it like this. 3 apples minus 1 apple will give you 2 apples. Now in multiplication in algebra, it's the same as if you think of one sheep being cloned twice. If you have A times A, that will give you A squared. If you have sheep times sheep, that will give you sheep squared, or S times S equal to S squared. If you clone the sheep 5 times, then the expression would be sheep times sheep times sheep times sheep times sheep to give you sheep raised to the 5th power. With division, you subtract. You say A squared, A to the 4th power divided by A to the 3rd, which will be equal to A to the 4th minus 3 equals to A. In algebra, when dividing, you subtract if the variables are the same. But when multiplying, you add the exponents with each other once the variables are the same. And you'll see that in my explanation as we move along in the video. Good luck, and I hope you enjoyed this video today. Bye. Welcome back. We're going to be doing algebra. What? I know, you probably are thinking, oh my god, algebra, yuck. But algebra is pretty simple, and like I would have explained in the earlier part of this video, all you got to do is know the operations. For instance, if you're adding, you just say how many of them you're adding back. So in this case, you're just adding here. We're dealing with addition and subtraction. So if you have 3 x's and 2 x's, if you're adding them, you're going to therefore have what? 5 x's, right? So you're going to have 3 plus 2. They have the same variables, so it'll be 5x. Now this one, same variables here. So therefore, 7 plus 9 is correct, 16. And if you don't know in your head, what I do in my head, I'm saying this would be 9. And if you take 1 out of 7, that would make 10. And if you take 1 from 7, that makes 6. So 10 plus 6, and you get 16x. Or you could just use your trusty old calculator and put 16y. And you put back the same variable. Now here we have 5z plus 7z plus 8z. And again, we go again, 5 plus 7 plus 8. All of them have the same variable, so we could just add them. And we're left with 20z. And we just put an equal sign here. And we come here, look at it again. Now we have 1, 2, 3 of these numbers having the same variable. So 4 plus 3 is 7, 7 plus 2 is 9. So we put 9a plus 7b. We can't add the b to the a because it's two different variables. So they're going to still be 9 apples plus 7 bananas. Okay, and let's make sure we add it up correct. So 3 plus 4 plus 2 gives us 9, and then we just bring back down the 7b because the variable is different. Here we have another one where we have different variables again. And so we have 6x and we have negative 2x. So remember, when the sign comes to the left, when the addition or subtraction sign comes to the left of that number, it tells us whether the number is positive or negative. So we have positive 6 minus 2x. Nothing else has an x, so we say 6 minus 2x. And you could group. If it's easier for you to group, you say minus 2x, and then you put, since this number looks bigger and nicer, we could put plus 7, because remember this says that this 7 is positive, and therefore this will tell us that this 3 is negative. Correct. So since this is all like it is, we say 6 minus 2 will give us 4x, and then we say 7, which is positive, minus 3 will give us 4y, and that will be plus 4y. Can we go any further? No. No, we can't go any further. Oh, well, let's move on. Let's try to group again, because this has different things. So we have 3ab, and we have minus 3ab, right? So we could say now that we group again 3ab minus ab, and we could say plus pq, because this is a plus in front of pq, plus 5pq. So this and this match, and this match. You see that? PQ and PQ. And so we say, if you have no number in front of any variables, you just say it's a 1. So 3ab minus ab will give us 2ab. That's like saying 3 minus 1. So 3 minus 1 would give us 2. And then we say now 1 pq plus 6 pq. So 1 pq plus 5 pq will give us 6 pq. This is 1 plus 5 with the same variable, so we say 6 pq. Okay. All right, moving right along, we have mn, and we have mn here again. So we're going to just underline that and underline this. So we're going to group mn minus mn, and this is minus, so it goes right there. And then we bring down everything else that are the same. They're the same. So we're going to say plus 4xy plus 17xy, and we're going to say plus xy. So if you have a 1 and 1, 1 minus 1 will give us 0. So that goes, and we don't have to worry about that anymore. But these instead, we have 4, 17, and 1. So 4 plus 1 will give us 5, and 5 plus 17 will give us, what is it? Again, use a trusty calculator. 5 plus 17 will give us 22. Correct? Yay! So we're going to have 22xy. So it's equal to 22xy. Yay! Now here we have LM. So we're going to say LM is positive, and we know 6LM is positive too, 6LM. Then we're going to put these two together because they have p squared q both of them. So you're going to say plus 3p squared q plus 14p squared q. And we say 1 plus 6 will give us 7 lm. These are all positive, so we add, and we say 3 plus 14, if you don't know, it's 17. So you could put it on in here. 3 plus 14, 17. And we just stick it on here. So 17, and don't forget your variables, p squared q equal, right? Then the last one that I'm going to explain on the addition and subtraction, we have here this x squared y squared and x squared y squared again. So we're going to put them together. So x squared y squared, this is positive, so it's a plus 3x squared y squared. So remember, this is positive because you have this sign to the left of it. And now we're going to have negative 4xy plus 13xy. So those are our two. You have x squared y squared, and then you have x and y. So we have to separate them. So if this is 1, this is like saying 1. So 1 plus 3 will give us 4x squared y squared. And then we'll say, since this is a smaller number than 13, we know that we would have a positive sign. This is like saying 13 minus 4. So 13 minus 4, if 13 minus 3 gives us 10, then 13 minus 1 more, which will make 4, will give us 9. So it's a 9xy. And that would be our answers. Great, so I hope you got all of those correct. Now we're going to do multiplication in algebra. It's pretty much the same, but with multiplication, you if you have variables, you just add the variables together if they have exponents, and you multiply naturally. So you would say 2 times 3a will give you 6a. Alright? Then here we have 4 times 3b. Everything just goes together. It's like you just mix everything. So you say 4 times 3 is 12, and you just put back the a and the b. Okay? Then here we have we have b and c, so we know our variables will be bc. But 3 times 2 is 6. 6 times 4 is 24. Right? And that will be our answer. Now here we have 2 of the same variables. So since we have 2 of the same variables, they're going to be squared. It's like cloning. So you're going to say a times a must be a squared, right? So you say a squared, and then you say 7 times 2 is 14. So 14a squared. Look at this one. 6 times 11 will give us 66, and we just put the a and the b together. So this is a little bit easier than the addition. Again, you just add in. So here we have a squared times a to the cube is like saying a squared plus 3. You just add in them. And then you say 7 times 3 is 21. And the answer would be 21a to the 5th power. Now here we have two negative numbers. Negative 4 times negative 2 would give us a positive number, which is a, because negative times a negative gives us a positive. Now we have a p here and 2 p's here, so we would add. So this would be p1 plus 2, and then we have q1 plus 3, right? Right there. And so we end up with 8p to the 3rd power and q to the 4th power. And this one is simpler than the one above. Whenever you're multiplying a negative number by a positive number or vice versa, you will always get a negative number. So you end up with negative 21y. And the last one, we have two negative numbers and a positive number. A negative times a negative will always give you a positive number. So it's a 2 times 5. It doesn't matter the order. You could go in any order you want to go. It's commutative. So you said 2 times 5 will give us negative 10. And then negative 10 times negative 4 will give us 40. So we get 40. And then we have 3 x's, so it's like x1 plus 1 plus 1, and that will give us 40x cubed. Yay. Okay, so remember, some important things to remember: a negative times a negative equals to a positive number. A positive times a negative will be equal to a negative number. A negative times a positive number will equal to a negative number, and positive times positive will equal to a positive number. Yay. Okay, and now for the last part, we're going to do division. So here we have 6a divided by 2. I'll advise you to write it like this: 6a over 2. 2 could go into 6 3 times, so you'll be left with 3a. Good? Then we have 6ab over 2ab. Again, 2 could go into 6 3 times. A will go into A once, and B will go into B once. So your answer will be 3. Here we have 7ab to the 4th over 3a cubed b. This is just simple, very simple. You just minusing, subtracting. So you would have 7 over 3, and then you can say you have a 1 minus 3, and then b 4 minus 1. So remember, this is a 1 here, and this would be a 1 here, right? And so you're going to be like this: 7 over 3, a to the minus 2, b to the 3. Okay? And we know that 3 into 7 goes 3.5 times. No, 2.5 times, I think. Well, let me check. So 7 divided by 3, yeah, 2.3. So we could put 2.3. And remember, anything that says 1 over a is equal to a to the minus 1. So therefore, a to the minus 2 is equal to 1 over a squared. So if you have a to the negative 2, put it underneath here, squared, and you keep b cubed up here. Right? And you're probably saying, what? Alright, it's pretty simple. Let me show you why. I'm going to show you why in another example. So here we have a squared b squared divided by ab squared. A squared is actually a times a, and then b squared is actually b times b, over a times b, right? And if you cancel, you're going to be left with a. But instead of doing all of this, what you can do, you look at this, you put a 1 here, so just to ease your mind, and you take everything that's in the numerator and just write it out nice and big. You look at the denominator, so this is the denominator down here. Everything underneath the line is the denominator. So you look at them and you say, well, a match back to a, and it has a 1 here, so we're going to just minus a 1. And b match back to b up here, and it has a 2, so we're going to just minus 2. So this from that, and this from that. And what you're going to end back up with is that you have a to the 1 and b to the 0. Anything raised to 1 is actually just itself. Anything raised to 0 is a 1. So this is saying 1, a times 1, because b to the 0 is a 1, and a times, anything times 1 will give you back whatever the answer is, which gives you a. Yay. So let's try this one now. We have 7ab to the 4th over 3a cubed b. And again, we could do it like this: 7 over 3, and we say a1 minus 3. And I think this is the same thing as like I did before, so I probably have the same question twice. So you write it like that, and you're left back with 7 over 3 a to the negative 2 and b to the 3. And just so it looks a little bit nicer, we could write this in decimal form, 2.3, and we say over a squared, and then we have b cubed right here. Yay. Now here we have this one, 4. I'm going to write it out just how you might be able to understand it. So this represents the a squared, and then this is going to represent y squared, and this is going to represent z squared. Then we're going to divide, and we're going to write it out just like how we understand it. X times y times y. So 3y represent y cubed, and then we're going to write out the z squared. From this onset, you have one x going, you have 2y's disappearing, and you have all the z's going, and you're going to be left back with 4x over over y. So you see how this could get confusing after a while? But it should have been so simple, and you could rewrite this as 4xy to the minus 1, because remember 1 over y is actually y to the minus 1, right? So if you wanted to do it the other way, you could have done it like this. You could have said 4x to the 2 minus 1, and then you say y to the 2 minus 3, and z to the 2 minus 2. And you would have gotten 4x y to the minus 1, and then z to the 0. And because z to the 0 is 1, you just write back 4xy to the minus 1. Is the answer the same? Yes. Okay, now we have p cubed cubed n over 6. Nothing can be done except you could write it nice. So you could say 6 to the minus 1 p cubed n. Because remember, 1 over 6 is actually 6 to the minus 1. Now, here we have 4, so this is your answer. So here we have 4x to the 5 over 7x to the 8. So you could say 4 over 7 x to the 5 minus 8. 4 over 7 x to the minus 3. And this could be written as 4 over 7x to the cube. Because remember, 1 over a squared is equal to a to the minus 1, such that same way as 1 over x cubed is equal to x to the minus 3. Okay? You can also look at it as 1 over a to the minus 2 is equal to a to the 2. It's just opposite. Why? Because if you say 1, remember 1 could be represented with any variable raised to the power of 0. And then x to the 3. So I'm doing this one. So if you do that, you will say x to the 0 minus 3. And that will give you x to the minus 3. That is why you get this answer. Okay? So always think like that. And then lastly, now you have 10 squared over 2. The 2 could only go into 10 5 times. So you're left back with 5m squared. Yay. So let me just recap quickly. Let's remember these easy things. 1 over a is equal to a to the minus 1. Why? Because 1 is also equal to a to the 0. So we could replace or substitute 1 for a to the 0, and we put an a over here. And therefore, if when you're dividing with exponents for variables, you have to subtract, you say 0 minus 1. Remember, a to the 1 is equal to a. Okay? So, you just say a to the 0 minus 1 would equal to a to the minus 1. That is why this is as it is. Okay? Just the same way as if you have 1 over 2, you could write it as 2 to the minus 1. Why? Because remember, if 2 to the 0 could be equal to 1, and 2 to the 1 is equal to 2, then we could substitute each of these. We could say 2 to the 0 divided by, then we know that we could say 1 over 2 is equal to 2 to the 0 over 2 to the 1. And therefore, 2 to the 0 minus 1 will be equal to 2 to the minus 1. That's why this could be equal to that. I hope this helps. See you around in the next episode. Peace. Did I put up 3 fingers? Oh, my shadow. Bye.